If you're going to measure the distance to a star, the only sure mathematical way is with parallax trigonometry, and you have to know two sides in one angle or two angles in one side. I taught trig for 15 years. This textbook says you can't measure more than 100 light years. I don't think you can measure more than 20 light years.
Let's briefly review how astronomers use parallax to measure distances to stars. Because the Earth orbits the Sun, its position in space is constantly changing. In particular, its position relative to any given star is constantly changing. This means that the direction that you have to look to see the star changes throughout the year. The further the star is from Earth, the less the direction to the star changes throughout the year. Now, the Earth, the Sun, and the star form a right triangle. The length of the bottom side of the triangle is just the distance from the Sun to the Earth, which is 92,955,888 miles. The length of the left side of the triangle is the distance to the star. The angle at the top of the triangle is called the parallax. You can measure the parallax by recording where on the sky the star is at two different times separated by 6 months. The parallax is half of the angle made between those 2 points on the sky. Once the parallax is measured, you can use trigonometry to find the distance to the star. In fact, because the actual parallax is so small, you can use an approximation to the true trigonometric formulas. It turns out that the distance to a star in light years is just 3.26 divided by the parallax in arc seconds. There are 3,600 arc seconds in a degree. So Hovind doesn't believe that we can measure parallaxes of stars that are more than 20 light years away. Well, if a star is 20 light years away, the parallax would be 0.163 arc seconds, or 163 milli arc seconds. That means that during a 6-month period, the star's position on the sky would change by 2 times 0.163 arc seconds, or 0.326 arc seconds. This is about 1/10,000th of a degree. So stars that are further away would have parallaxes less than 163 milli arc seconds. Because remember, the further away a star is, the less its angular position changes, and thus the smaller its parallax. Here is a table of parallaxes of white dwarfs as measured by the Hipparchus satellite in the early 1990s. As you can see, of the 21 white dwarfs listed, 18 have parallaxes less than 163 milliarc seconds, and thus are more than 20 light years away. Hovind has no excuse for saying that we can't measure parallaxes of stars more than 20 light years away, because these measurements were made 10 years before he spouted off these ridiculous statements.